I want you to take a moment and just completely discard everything you think you know about how buildings are made. Seriously, toss out the blueprints, forget the static concrete blocks, and ignore those rigid steel grids. Welcome to the era of the algorithmic architect, where our urban environments are no longer just built from the ground up, they are literally grown.
So what if your apartment building was alive? Now, I know that sounds straight out of a science fiction movie, but if we look at the latest data on generative design, it's rapidly becoming our reality. We're standing at the absolute edge of a massive revolution in sustainable architecture, a space where the line between a biological organism and a fabricated structure is being entirely erased. Okay, let's dive into this explainer and see how we got here. For centuries, architecture was heavily bound by the sluggish friction of the drafting table. Traditional manual drafting relies on human intuition, which, don't get me wrong, is remarkable. But frankly, it kind of fails when forced to account for incredibly complex variables all at the same time. Think about trying to mentally calculate intricate fluid dynamics, real-time solar gain, and complex material load limits all at once. It's just impossible for a human brain to optimize all of that perfectly. But in AI, it calculates these variables in absolute seconds, generating thousands of instantaneous structural possibilities before a human architect could even finish sharpening a pencil. And because of this massive shift in computational power, the very philosophy of human creation is fundamentally changing. We're essentially seeing the death of the architect as a literal illustrator of floor plans. Instead, we're shifting toward the architect as a curator of algorithms. The human becomes this masterful director, setting the constraints, the goals, the practical parameters, while the AI explores a vast multidimensional space of solutions to find the absolutely perfect physical form. So what does that perfect physical form actually look like? Well, it looks exactly like nature. By using evolutionary algorithms, these AI systems are practicing biomimicry, basically copying nature's most efficient blueprints. They're generating these wild, organic, bone-like structures that eliminate excess mass everywhere it isn't strictly needed. The results? These algorithmically generated designs use a staggering 40% less material without sacrificing a single ounce of structural strength. Imagine buying a large coffee but only having to pay for a small. That's the kind of massive reduction in material waste we're talking about here. But reducing waste is really only half the story. The AI models we're seeing deployed right now in the 2026 data are integrating something incredible called living materials. You see, these algorithms don't just calculate where the steel should go. They map out exactly where carbon-sequestering components can be infused directly into the building's matrix. This means we're moving way past just being carbon neutral. We are designing structures that actively inhale pollution and heal the environment, operating much like a natural forest canopy right in the middle of a concrete jungle. And this brilliantly illustrates how biomimicry finally cracks what urban planners have long called the impossible triangle. Historically, you know the role. You could only ever pick two. You could have high density and low cost, but it would be ugly. Or you could have aesthetic beauty and low cost, but you wouldn't get high density. Well, generative AI solves all three simultaneously. We get high density through incredibly efficient algorithmic spatial stacking. We get low cost because of that massive reduction in material waste. And we get stunning aesthetic beauty because organic biomimicry naturally produces these sweeping bone-like curves that are just incredibly pleasing to the human eye. Let's zoom out for a moment and look at the exterior of these buildings. Generative models actually simulate the real world before a single brick is even laid. By continuously simulating the elements, the AI analyzes vast data sets of real-time weather patterns specific to that exact geographic coordinate. It then mathematically angles every single window, every overhang, and every surface to completely maximize natural heating and cooling. We're finally shifting away from passive, dumb structures that fight the environment to highly optimized shells that work seamlessly with it. Now, what's really fascinating is how that environmental optimization plays out dynamically in real time. These are kinetic buildings. They physically adjust their skin based on algorithmic environmental feedback throughout the day. Let's just walk through this daily cycle. In the morning, the building opens its automated louvers for a solar harvest, soaking up that natural warmth. By midday, as the sun beats down, the skin dynamically shifts to provide heat deflection, perfectly shading the interior. And in the evening, the structure physically opens aerodynamic channels to allow for natural ventilation. I mean, the building is practically breathing. When you multiply this kinetic, algorithmic approach across a whole neighborhood, you completely revolutionize urban city planning. For decades, we've relied on rigid urban grids, which tragically trap heat and create massive urban heat islands. But by turning the AI loose on city layouts, it abandons the grid entirely in favor of wind-optimized building clusters. The buildings are positioned almost like stones in a river, specifically angled to channel cool breezes down to street level and drastically reduce urban temperatures naturally. But of course, a building's survival isn't just about its exterior skin, right? It's about the life breathing inside it. So let's shift our focus inward for a second and look at how this algorithmic revolution transforms micro-livability for you and me. As global populations keep rising, urban space is at an absolute premium. We're living in smaller spaces, but AI ensures those tiny footprints don't feel like cramped little boxes. Generative design curates the interior by meticulously optimizing internal airflow so the air never feels stale. It guarantees maximum natural light penetration, even curving interior walls if necessary, to bounce sunlight into the deepest corners of an apartment. The end result is an algorithmically balanced room layout where literally every square inch serves a deliberate, functional purpose. Which brings us to one of the most fascinating trends captured in this 2026 data, the concept of elastic spaces. Generative design allows for deeply modular interiors. So instead of forcing a resident to pack up and move out when their life changes, the apartment itself actually evolves alongside the tenant's specific life stages. A layout optimized for a young professional can physically shift its modular internal partitions to accommodate a growing family, or dynamically create dedicated zones for remote work integration, before eventually downsizing its internal footprint for an empty nester. The architecture is no longer static. It becomes this temporal, evolving partner in your life. There is also a profound psychological layer to all of this. Look, humans simply weren't evolved to live inside right angles and concrete cubes. Generative design inherently creates spaces that subconsciously mimic the mathematical patterns, the fractals, found in natural forests. Studies are already showing that these algorithmically generated organic curves dramatically reduce urban claustrophobia. Just by changing the geometry of the walls to reflect nature's blueprint, we're creating built environments that actively enhance mental well-being. We are literally engineering peace of mind directly into the floor plans. Now, if we zoom all the way out from the individual apartment past the kinetic building, we arrive at the macro level, the autonomous living city. This is the point where generative architecture transcends the individual structure and connects every single building into a larger, interconnected urban nervous system. So the absolutely crucial question is, how do we actually build this incredibly complex, nonlinear city? Human hands alone can't pour concrete into these intricate, bone-like fractal shapes. The realistic rollout happens in phases. Year 1 requires leveraging advanced 3D printing at scale to extrude these generative shapes right on site. Year 2 brings full robotic assembly integration, using drones and automated cranes that can read the AI's complex geometric blueprints flawlessly. And by year 3, the nervous system comes online, launching block-to-block energy sharing, where these kinetic buildings dynamically trade their harvested solar energy and thermal resources with each other completely autonomously. All of this data, all of these generative algorithms, they lead us to a powerful crossroads in human history. As we look at these living, breathing structures designed by artificial intelligence, we really have to ask ourselves, are we finally prioritizing ecological survival over architectural vanity? For thousands of years, buildings were monuments to human ego, rigid, unyielding, dominating the landscape. Today, the algorithmic architect is teaching us a new humility, showing us that the smartest way to build our future is to step back and let nature, guided by the machine, design a world that actually wants to survive.